Good morning and good afternoon, everybody. My name is Petr Klomfar. I am product owner for CA Mainframe Application Tuner. Thank you, Kate, for handing the presentation over to me. Let me walk you through our implementation of functionality of performance on commit. So here is the diagram before we jump to the demo, to the actual demo. Here is the actual diagram of our implementation, and we will be focusing from the perspective of Michelle, who's the modern developer. She's going to update the code in IDE of her choice. In our case, it will be Visual Studio Code. She will save it, she will stage it, she will commit it to her GitHub repository, and the change from the GitHub to the backend to the Endeavor will be propagated through integration with CA Endeavor Source Code Manager throughout the Enterprise Git Bridge solution. On the Endeavor, when the change appears in the source code manager, we have a webhook server listening to update action, but it can be any generate in place. It can be staging from dev to the QA environment, but in our case, it's update action, which triggers our CI/CD pipeline that is being orchestrated by Jenkins, and that is where CA-Med Detect as part of performance on commit comes in place and collects the performance matrices. I will walk you through the details in the actual pipeline, but at this stage, Michelle can already use get performance commands or get alert commands to get some matrices directly from the CLI. But to make it easier for her, we actually provide emails. So performance report will be generated and sent to the Michelle. And in our case, we will focus on the alert in the dreadful situation that the performance degradation appeared. She will receive similar email like this. Let me walk you through in a minute during the demonstration. And this is also when the alert is generated where CA-Med analyze component is being kicked off and automatic measurement of the performance degradation or the program under test is being done. So she can then drill down into the details using the CLI commands respective to CA Mainframe Application Tuner, bring up, for example, the overview of the program, take a look on the history of the measurements, or she can drill down into the code view and CSEC section and inspect what is the issue and what's the culprit. Without any further ado, let me switch to the Visual Studio Code. Here we are, and I will make some change on behalf of Michelle. So, for example, I will change this subscript in the main line. I will save the change, as I said. I will then stage the change. When the stage is staged, I will commit it to a GitHub with the demo command, so we are transparent here. And whenever I am ready, I will push into the repository. This is where our pipeline will be triggered. So I can see a passphrase, because security first. Okay, I can see that changes has been successfully pushed. Well done. Now let's switch to our CI/CD pipeline. I should see pipeline kicking up in any second. Yes, there is a pending pipeline. Whenever it kicks off, I will open it in the blue ocean because it's easier to observe. So when I'm in the blue ocean, this is how the internals of the pipeline looks. On the background, AutoGen job is being kicked off to generate the job in the source code manager. Then the actual application or the job is being submitted to the mainframe processing. Throughout that, PMA as a component of CA-Med Detect collects the SMF records and compares them with the KSDS clusters for jobs and alerts for comparison, and then the summary report at the end is being sent out. When I'm looking at the email, what Michelle is going to be receiving, within the normal range is where everything is fine and we have a bright blue skies. We have these tiles. These tiles are CPU deviation, elapsed deviation, XCP deviation, and service unit deviation. They basically can have some variations dependent on the load of the machine where the job is submitted. Also in the email, we provide the performance test details for average values for the baseline or for the current versus previous run. And I should receive the email any second. Let me double check the Jenkins pipeline. Oh, there it was. So let me show it. And as you can see, the performance degradation was significant enough. So we have received an alert status. The alert status itself will be similar with the red tiles, and it's going to be providing the Zoe commands for Michelle to easily drill down. So we will jump directly to, for example, delay view. And if I just copy the Zoe command, go back to the terminal of my Visual Studio Code, and I will paste it, I should be able to bring out the delay view of the CMET measurement. Yes, there it is. So I can see that the program active was 45% of the whole run of the application. So that's the one that I want to inspect the most. Let me just do advanced command, Zoe mat monitor delay view addresses for this specific profile for the major and minor category of the program activity. If I press enter, I should receive the more granular information. And when I take a look here, it's a COBOL program. The statement in the COBOL program can span through the multiple offsets. So let's pick the one which is the heaviest. That's 9 delta 2. And I would be interested actually to see within the listing. So excuse me, I can also bring up the listing from the another integration from Endeavor. So the listing should be coming in a second. There it is. And when I take a look into the assembler code, respectively, let's search for that 9 delta 2. So the 9 delta 2 was actually part of the instruction at. It was a zap in this case, but it was at instruction, as I can see, and that instruction was part of the subscript -100 label. So if I scroll up to the actual source code from the listing, I am looking for subscript -2, and this is exactly the perform that I have changed for 12,000 times, which is the main loop. So this is what caused the degradation, and this is basically the demonstration how user can bring up and utilize the value of the performance on commit functionality. Let me get back for my PowerPoint presentation still, because if you happen to be a user of CMET, you can utilize these links to download these CLI integrations for CMET detect and analyze, straightforward. If you happen to be our customer or even observer from outside, we will be very happy to hear from you, your DevOps experience, your stories from the performance tuning. And you can reach out to us. We will gladly hear what you have to say, and please reach out to me as a product owner or to Kate as a product manager. We will be really happy to hear. Also, as a reminder, Broadcom is a partner on your DevOps journey. So we realize that your DevOps transformation can be challenging, and none of those, or there are now no two alike, I should say. But we are keen to work with you and help you to peel off the layers and to help you to disassemble the impediments that you may have on the road. And to demonstrate our commitment and partnership offerings, we offer these items that you can see on the screen for our loyal customers free of charge. So we would be able to help you with the design thinking, with the environment preparation, hands-on workshop, or even proof of concepts. So be sure to reach out to us. We'll be happy. And with that, basically, thank you for your attention and for your time being with us through the demo. And should you have any feedback or any questions, please fire them up.